The day buildings learn to heal themselves, the living concrete revolution is already here. Imagine this. You are driving across a bridge built 50 years ago. You trust it. You rely on it. You never think about it. But inside that concrete, tiny cracks are forming, invisible at first, then slowly spreading. Around the world in 2026, this silent aging of infrastructure has become one of the most expensive problems humanity faces. Bridges, tunnels, dams, airports, office towers, all of them are getting older, and repairing them costs trillions of dollars. Not just money, time, labor, and enormous amounts of CO2. The traditional model has always been simple: build, wait, fix, repeat. But now a new idea is emerging, an idea that feels less like engineering and more like biology. What if buildings could heal themselves? Concrete that acts like living tissue. Scientists and engineers have developed something that sounds like science fiction: self-healing concrete, a material that repairs its own cracks without human intervention. The secret is surprisingly small. Bacteria. Not harmful bacteria, not dangerous bacteria, but specially selected microorganisms that remain dormant inside the concrete for decades. They sleep, they wait, and when a crack forms and water seeps in, the bacteria wake up. Then they begin to work. They consume nutrients embedded in the concrete, and they produce limestone, the same mineral found in natural rock. Slowly, steadily, they fill the crack from the inside, like skin closing a wound. No workers, no machines, no scaffolding, just biology doing its quiet repair. This is why researchers now call it self-healing material, and it may redefine the future of construction. The real cost of cracks. At first glance, a small crack seems harmless. But in infrastructure, a crack is never just a crack. Water enters, steel reinforcement begins to rust, expansion follows, strength weakens. Eventually, entire structures become unsafe. In the United States alone, tens of thousands of bridges are classified as structurally deficient. In Europe and Asia, many major buildings built during rapid economic growth are now reaching the end of their designed lifespan, and replacing them is not sustainable, because cement production itself is responsible for nearly 8% of global CO2 emissions. That makes concrete one of the most climate-intensive materials on Earth. So the question is no longer, how do we build more? The real question is, how do we make what we build last longer? From maintenance to immunity, self-healing concrete changes the entire philosophy of infrastructure. Instead of constant repair, structures gain something closer to immunity, not perfection. Not invincibility, but resilience. Just like the human body, a cut appears, the body responds, the wound closes, no external intervention required. Engineers now describe this new approach as bio-integrated architecture, where biological systems are embedded directly into buildings, not as decoration, not as technology layered on top, but as part of the structure itself. Concrete becomes more than a material, it becomes a system. The house that outlives its owners. Now imagine applying this technology to something closer to home. Not a bridge, not a highway, a house. A building designed not just for one generation, but for many. A structure that quietly maintains itself, year after year. No sudden repair bills, no emergency maintenance, no hidden structural decay, just steady durability. This idea transforms real estate from a cost into something else entirely. A long-term asset, a living asset, one that protects value across decades, and perhaps even centuries. In the future, families may inherit homes that are stronger than when they were first built, not because they were repaired, but because they were designed to heal. Why this matters for the climate. Infrastructure repair is not just expensive, it is carbon-intensive. Every repair requires new materials, heavy machinery, transportation, energy, all of which generate emissions. Self-healing structures reduce that cycle. Fewer repairs, less material, lower emissions. This is why many climate researchers believe self-healing materials could become one of the most important tools in sustainable construction. Not flashy, not dramatic, but quietly powerful, like roots stabilizing soil beneath the surface. The shift already beginning. Self-healing concrete is no longer experimental. It is already being tested in bridges in the Netherlands, water infrastructure in the United Kingdom, public buildings across Europe, road systems in Asia. Governments are paying attention because maintenance costs consume massive portions of national budgets. In many countries, repairing aging infrastructure now costs more than building new infrastructure. That is not sustainable. But materials that repair themselves change the equation. They extend lifespan, they reduce risk, they stabilize budgets, and they make long-term planning possible again. The philosophy behind the technology. For centuries, construction followed a mechanical mindset. Materials were expected to resist damage. Strength meant rigidity. Durability meant thickness. But biology offers a different lesson. Strength comes from adaptation. Resilience comes from recovery. And survival depends on the ability to heal. Self-healing concrete represents a shift from mechanical thinking to biological thinking, from resistance to regeneration, from maintenance to self-preservation. It is not just a new material, it is a new philosophy of building, the future of infrastructure. One day, future cities may be filled with structures that behave more like ecosystems, bridges that seal their own cracks, roads that repair surface damage overnight, buildings that monitor and maintain themselves. Invisible systems working quietly beneath the surface. No headlines, no drama, just reliability and stability. The kind of infrastructure people rarely notice, because it simply works. The moment everything changed, history often remembers dramatic inventions. Electricity, steel, the internet. But sometimes the most important revolutions are quiet. They happen inside materials, inside systems, inside the foundations of everyday life. Self-healing concrete may be one of those revolutions, a technology that does not shout, but endures, not by resisting damage, but by recovering from it. Final thought. For centuries, humanity built structures that slowly decayed. Now we are learning to build structures that can recover. The shift is subtle, but profound, because the future of infrastructure may not depend on stronger materials. It may depend on smarter ones. Materials that behave less like machines and more like living systems. And when that happens, buildings will no longer be static objects. They will become partners in their own survival. If this kind of future interests you, follow Hope Reactor, because the next revolution may already be growing, quietly, inside the walls around us.